Hello. Hi guys, my name is Humayun Jamal, and I'm here to present something what I experienced using ECS, my love with ECS service. I'm working as a DevOps practitioner in a PropertyFinder group. PropertyFinder is a property portal in UAE, and it's one of the best, and actually number one in UAE, as this tagline is used by every company in UAE, we all know. So yeah, we are a very good tech company. I'm sure you'll all be surprised why I'm saying that, but once you get to know the stack, the team, and the guys we are working with, you'll surely appreciate it. Anyways, moving on. Yes, that's me. So what is Elastic Container Service by AWS? So it's a Docker container scheduling service like Kubernetes, Mesos, etc., but with very less features and customization. I hope the AWS experts here are listening who are from AWS, yes. So yeah, it claims to be as equal to Kubernetes, but it's not. But on the positive side, you don't need to know any depths of scheduling services like Kubernetes and Mesos. You don't need to know everything about them. You can simply start using ECS from within a few hours of tutorials, which are not available on generally. And it does not follow or exactly map with all the Docker features as posted by Docker, and also it always lags behind the new Docker versions. It does have certain features, but it also have very annoying limitations. For example, memory reservations and non-flexible resource management. So if you do not calculate how much memory your container is going to use, it will block it, it will destroy it, and you will not even know it unless you are logging and doing alerting, implementing extra services to just monitor that. So yeah, what happened here? Yes. So as you can see, my creative skills, ECS task definition. So how can we create it? How can you start using it? So you need to create a very old format of task definition in JSON, of course. It's almost like a Docker Compose file. It almost maps all those hook names or the variables, you can call it. It almost maps exactly the same as Docker Compose file, but it's not completely same. So from those task definition, ECS service will accept that task definition, and then it will run ECS task as you instructed. So if you want to run coupled containers, if you want to run one container per task, ECS task service will understand from this file or JSON definition, and then it will run on this host, which is a cluster. And you create this cluster. Basically, these are simple EC2 auto-scaling groups, which has to use an ECS optimized AMI. So this cluster can have one instance or many EC2 instances. It depends on your requirements, and it can auto-scale based on metrics which you configure. And then we have this ECS service. So service controls the task distribution on each host machine. It also controls the state of the task. It also controls the auto-scaling of tasks, not the auto-scaling of EC2. So start with the example. We are using it to host a web application. So I will, all my slides are based on, or my example is based on hosting a web application using AWS ECS service. So classic ELB, so if you're hosting an application which is listening or which is posting on port 8080, and if you want to host it outside, classic ELBs are not a good fit for ECS service because it can only support static port mapping. And if you are running an auto-scale environment, if you want an auto-scale environment, of course, the container cannot run with the same port on the same machine. So what to do next? So the next is, or the solution is, use application elastic load balancers. So when you use elastic load balancers, it uses dynamic port mappings. I'm sure you guys have worked with AWS application load balancers. These are intelligent load balancers. I would suggest everybody to test it if they haven't used it. And I think converting to application load balancer is a much better option than the classic ELBs. So it has dynamic port mappings, so it works absolutely in a good way with the ECS service. And then you can have any number of web containers spread across the hosts, and you can launch in any dynamic port which will be automatically detected by the application target's elastic load balancer. I said target because application load balancer uses a target group, and target group actually detects the dynamic port mappings. Okay, so the features of auto-scaling service provided by ECS, we have 2 layers of auto-scaling. So one is at a service level, so you can tell ECS, or you can configure ECS to scale on the basis of memory reservation or usage or metrics, CPU metrics. If the CPU metrics increases, you scale the containers. And the second level of scaling is the host is hosting on. So EC2 or auto-scaling groups can scale on the typical metrics available on AWS. You can also use customized metrics. So service scaling is based on custom metrics. If you try to use custom metrics, which we did, it's kind of tricky. It's not completely automated. It cannot be completely automated with CloudFormation. Yes, if you use Terraform, then yes, there is a possibility. So it has a lot of moving targets. If you start using custom metrics, then you don't know exactly. You have to track them. You need to have a separate service to track them and know what's going on, what happened. You need to have good alerting service, so you know what's actually happening. So service scaling can be done by the metrics, and the scaling metrics for service provided by AWS is memory and CPU reservation. In the next slide, I will tell you what is memory and CPU reservation. So based on application behavior and response, the memory CPU reservation should be carefully configured, so you do not end up with too many containers or too less containers running on your hosted or host services. And the deployment. The deployment strategy provided by ECS is very limited. It's only one deployment strategy, which is rolling deployments. As new task versions get in line for deployment, the scheduler creates a new task based on the healthy percentage or maximum healthy percentage you have configured. So it makes sure that percentage of healthy containers are live and running and servicing the request, and then it creates extra containers as it feels, and then it replaces slowly. So it also drains the connections from the old containers, and then move the container or use the Docker stop command, stop the containers, and then replace it with the new container. So that's something which I liked about it. But then your application has to be supportive of this provisioning stuff. So this strategy is a letdown in other cases, but if your app versions are always forward-backward compatible, which is a utopia indeed, then you're all set. You will enjoy this deployment strategy. So what images or what imaging service or registry you should use? AWS ECS provides you a service called ECR, Elastic Container Service, which is provided by AWS as a local service. But I did a bit of benchmarking on the speed on Docker Hub and this AWS ECS, and it was actually not that much different. So I would suggest to use your own AWS hosted, your own registry. It's even better because ECS acts really weird on your laptops. It will sometimes will not work, and if you go out for a smoke break and come back, it will be fine. So, and I've opened lots of cases with AWS support. They have no clue what's going on, and they just simply say, why don't you just restart your container service or agent, which is not actually connected to AWS ECS. So yeah, logging. ECS has a very basic dashboard with very limited error reporting. It just throws some error in your face. Then it's up to you to log into the host, tail the agent's log, or you can send the agent logs to your Elk stack and then figure out what's going on, and then Google it, of course. Application logging can be done by shipping to a central location, of course, using Filebeats or anything you're using in your own environment. But yeah, that's not something provided by AWS ECS, and yeah, the dashboard is really bad. Oh yes, monitoring. So of course, AWS monitoring is amazing. Only two metrics available: memory and CPU reservation, which is nowhere else used or visible in AWS. Monitoring has to be done using our own method tools. So whatever you're using or in your own environment, I would suggest to use that. This memory reservation and CPU reservation is only good for controlling. If you know your application, how is it performing, or what are the constraints, then you do some calculations based on that and spread. So you make sure when the containers launch, you know one host of EC2 of M4.X large or whatever will create 4 containers, or will have 4 containers or 14 containers. So you know it's kind of controlled environment. But for other metrics, you have to use sysdig, which I would recommend. It was an amazing blog. I did got time to use it myself. And of course, Docker container monitoring is very tricky, always. This is what I found out in my 1 year of experience in using containers extensively. The monitoring part is very tricky, and if you don't do it well, then Docker containers or the instances running your containers is always a magic box or a black box, and you don't know what's going on or how will it react under certain conditions. Okay, automation of this ECS. It's, of course, as other AWS services, it has got a very poor integration from CloudFormation. Last I checked or created a CloudFormation template or tried to create a CloudFormation template in January. Terraform can produce a complete ECS stack with both autoscaling, service autoscaling and EC2 autoscaling configured with application load balancer and target group as well. So yeah, I have to try it first. I've heard from big companies that yes, it works well with ECS automation. It cannot use persistent storage. Maybe if you want to, then you can use EFS, which is still under in a beta version. It's not a perfect service right now. So yeah, and task definition. So task definition is it's a huge JSON file. So I would recommend templating it using Ansible or Jenkins or whatever. What we do is we use Jenkins to create an image, create the perfect golden image, and then produces that Jenkins job produces an updated task definition, which is then fed into AWS ECS CLI, and then it goes through and replaces the old task and create a new service. Yes, so every ECS host is running an agent provided by AWS ECS, which controls all the automation part of AWS. That agent has got, since from version 1, it had a lot of bugs. So they are now paying attention on the agent, and they are fixing a lot of bugs, but it's not there yet. Yes, you don't need to clean up the old images anymore on ECS hosts, but you still, just to be on the safe side, you still need a 2000 GB volume. So yeah, and the agent is also lacking version upgrades from Docker. So, but the good thing is, at least it's stable. At least they're using the stable versions of Docker. Okay, so final verdict. Not many people are talking about it on blogs or YouTube or SlideShare. Not much support or use cases of ECS is being shared in the community. So even though I spoke to many people in the community and they were using it, but they are using it as a test service, not in production. I can understand from the deployment strategy and the drawbacks. You have to come up with so many things, create so many extra services just to make it closer to Kubernetes or Mesos or Swarm. So I guess people just think if it's a lot of work, let's just use Docker Swarm because it has a bigger community, it has a bigger blog post, it has a good how-tos. So it's good for some very specific use cases. For example, you can run your batch services in ECS. So in that way, it's good, but it's not close to, yes, I think I have mentioned it many thousand times, Kubernetes and Mesos. Deployment strategy is a big drawback. You cannot use it for a live complex application. You need to create your own cluster. If you want to go blue-green, then you have to create your own separate cluster. And then switching between blue and green or testing it is also kind of a manual, your responsibility to do that or come up with a solution for that. Memory reservation is a good metric to plan and control the scaling of the environment. As I mentioned before, this memory reservation can be used to control exactly how many containers should run in per host basis. So that works really well with the auto scaling feature of EC2. So what it does is if there is a surge of requests, so it will automatically detect that yes, I will need at least one more host instance to host at least one more Docker container. So it will automatically, just to be on the safe side, it will automatically create a new instance and that instance will be ready to host your Docker containers. So that was a very good feature which I think can work very well with other technologies. But yes, here AWS ECS did a good job. And yes, this CPU reservation just does not work. So no metrics really explain how it is supposed to function. I did a lot of digging around. I did a lot of customized monitoring, but it just doesn't, I don't know why it's there. And if it's there, why it doesn't function. So yeah, that's pretty much it. Any questions you can ask on the pizza. Cool. Thank you, man.